Okay, here we have a log equation where our unknown, our variable, is in the argument. Now, the argument, if we look back to the graph of our log function, the domain of our log function, it comes from the argument. And remember that argument needs to be positive. So this argument has to be positive. So let's make ourselves a note. The argument must be greater than 0, not even equal to 0. And that's because the base, remember that the base is also positive, but not equal to 1. When you have that positive base, a positive base raised to any power, it's going to equal a positive number. No doubt about it. That's exactly what's going to happen. So we're going to take this positive base, that's this right here, raised to any power, whether it's positive or negative, any power is going to result in a positive number. So hopefully you can see that from the color coding that I am trying to use here. Our first step is going to be writing the equation in exponential form. So we're going to write in exponential form. So that's our first step. It's going to be to write in exponential form. So we're going to have 25 raised to the 3/2 power is equal to x. Step 2, we just need to simplify. So step 2, we're going to simplify. Sometimes that means also calculate. So we're going to do a little calculation. We're going to take the square root of 25, and then we're going to take that result and raise it to the 3rd power. The square root of 25 is 5. 5 cubed is 125. Step 3, you have to confirm / check to make sure that the solution is workable, that the solution works and doesn't result in an argument that is less than or equal to 0. We do not want an argument that is less than nor equal to 0. So when I take this 125 and I put it back in to my equation, log base 25 of 125, the argument is positive, therefore x equals 125 is our answer. X equals 125 is our answer. Okay, on this next example, we are going to need a calculator. So we're going to need a calculator on this next example. You go ahead and try it, and when we come back, I'm going to give you the answer, and we'll see if our answers match. So go ahead and press pause. Take some time. You're going to need to use the quadratic formula. So recall the quadratic formula, and then come back and see if our answers match. Okay, our first step is to write in exponential form. So 10 squared is equal to 2x squared minus 3x. That's going to be 100 equals 2x squared minus 3x. We'll set our equation equal to 0. And then we're going to try and solve this. It's not factorable. So I'm going to say x equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. We get 3 plus or minus the square root of 9 plus 800 all over 4. 3 plus or minus the square root of 809 all over 4. Now, 30 times 30 is going to be 900. 30 times 30 is 900. So the square root of 809 is less than 30. It's less than 30. If we put this into our calculator, we're going to get a positive answer, we're going to get a negative answer. One answer is going to be 7.861. That answer comes when I add 3 plus the square root of 809, and then I take that result and divide by 4. And this is approximate because I'm rounding. When I subtract 3 minus the square root of 809, I get negative 6.361. Now remember, we have to check both answers. Check to make sure the argument remains greater than 0. Now, if either one of these answers don't work, we're going to call that answer extraneous. If they both work, then they both work. So here we have log base 10 of 2x squared minus 3x equals 2. If I put a positive 7 in, 7.8, if I take this positive 7.8 and I put it in, it's about, let's just say 8. 8 squared is 64. 64 times 2 is 128. 7 or 8 times negative 3 is negative 24. 128 minus 24, that's a positive number. So this one works. If I put a negative 6 in, negative 6 squared is about 36. 36 times 2 is 72. Negative 3 times negative 6-ish is positive 18. I'm going to have a positive number times a positive or plus a positive number. So two positive numbers added together will give me a positive number. So both of those answers keep the argument greater than 0. Therefore, both of those answers are solutions. Both are solutions. Now we're going to make a note. When an answer causes the argument to be less than or equal to 0, it is called extraneous. It is called extraneous. Okay, coming up, we're going to deal with some equations that use the properties of logarithms. So we're going to put everything together that we've learned so far, and we're going to start solving some equations that look a little bit more complicated, but really we're just going to use some of our tools that we learned in previous lessons where we condense logarithmic equations or expressions. We're going to be using some of that condensing to make the equations more simple, and we're going to continue solving logarithmic equations.